Hi everyone, welcome back. Let's see one of the gate question which was asked in the year 1998 on the concept of banker's algorithm. Let's read the question. Consider the resource allocation graph in the figure and you need to find if the system is in deadlock state or not. If it is not in deadlock state, find the safe sequence. So this question you can able to simply solve by looking into the graph, or we can go with some kind of tabular representation where it will be easy for you to solve this one, right? So what are the processors available for us? Processors are P0, P1, P2 and P3. And what are the processes for which resources are allocated? Resources are allocated. How many resources are there? Now we are having three resources are there: R1, R2 and R3. Similarly, what are the resources which are needed or which are requested to perform its operation? So that I am going to represent like this, right? So what are the resources that are allocated for the P0? Just try to think, right? As already said, the incoming edges defines allocated. Incoming edges allocated, right? How many incoming edges are there for P0? Two incoming edges are there, which are related to one is R1, another one is R3. So for R1 I will make 1, for R3 I will make 1, and for R2 it is not there. Similarly, what are the outgoing edges are there? Outgoing edges represent need or requested. See guys, incoming edge defines allocated and outgoing edge defines the need, right? What are the outgoing edges are there for P0? 1 will be 2 R2, 1 will be 2 R3. So for R2 and R3 1 will be there, and for R1 it is not an outgoing edge, so that is 0 1 1. Similarly for P1, what are the incoming edges are there? One will be from R1, another one from the R2. So R1, R2 and from R3 I am not getting anything. What are the needed requests given by P1? That will be for only R1. So I can say that it is 1 0 0. For P2 similarly, incoming edge is from R2, and from the remaining things I am not getting any incoming edges. Similarly, the outgoing edges of P2 will be to R3. So I can say it as 0 0 1. Similarly for P3, what are the incoming edges are there? Only R2. So I can make this as 1 and the remaining two are 0 0. And what are the outgoing edges? Outgoing edges are for R1. How many outgoing edges are there? 1. And for R2, any outgoing edges are there? Yes. How many outgoing edges are there? 2 outgoing edges are there. So I can make this as 2. And for R3, nothing. So I can make it as 0. Good. Right? So trying to write the graph representation in terms of table representation, it is better and easy to solve the given question. Why? Because here we can able to apply the banker's algorithm. Right? That also we have seen in the earlier videos. Right? Now, in order to solve this banker's algorithm, we have to know what are the available resources for us. What are the available resources of R1 and R2 and R3, right? So what are the available resources means what? First, R1 having how many resources are there? 2. R3 having how many resources are there? 2. R3 having how many resources are there? 3. Good. Right? Which means that the total number of resources are of R1, R2, R3 are 2, 3 and 2 guys. 2, 3, 2 and 2. And if you want to find what are the resources which are available for us, out of the total resources available, how many are already allocated, that you have to find, right? How many are already allocated, that we mentioned in this particular here, right? So the total resources which are allocated are, just calculate this one. This is 2 and this will be the 3 and this will be the 1. So total already allocated are 2 3 1. So from total resources, if you are going to remove total allocated, you are going to get available resources, right? 2 minus 2, that is 0, 3 minus 3 is 0, and 2 minus 1 1. So now available resources so far are 0 0 1. Now try to apply the banker's algorithm so that you can solve it easily. Is need 0 1 is less than or equal to 0 0 1 condition file. Is 1 0 0 less than or equal to 0 0 1 condition file. Is 0 0 1 is less than or equal to 0 0 1? Yes, satisfied. When it is satisfied, I am going to subtract that one from here and will be added to the allocated. Right? Already we are having 0 1 0 as the allocated. If you are going to add 0 0 1, what will the getting you are going to get? 0 1 1. Right? Then what about the need? Need will be modified as 0 0 0, guys. The point here is it's a kind of explanation, so I am trying to take step by step of the algorithm. But when we are going to solve in the gate examination, you need to worry about all the things. Just go with the flow, how you have practiced, right? Yes. Now definitely after certain point of time, P2 completes its task, then will be given back to the operating system. So now earlier we are having 0 0 0 is the resources. Now we added back as 0 1 1. So the total available resources are now 0 1 1. Guys, for the safety purpose, I am trying to maintain safe sequence also. If it is free from the deadlock, I can get safe sequence, right? So that's why I already completed P2, so that's why I maintained P2 separately. Now 0 1 we got. When you got 0 1 is 0 1 is less than or equal to 0 1? Yes, condition is satisfied. Then what I can do? I can subtract it from the available resources. I can make it as 0 0 0. That I will be added to the existing allocated resource, right? Then we can get 1 1 2. We can get 1 1 2, right? So the needed now turn it to 0. Definitely after certain point of time, that 1 1 2 will be given back to the system. So you are going to get as again 1 1 2 is available so far. 1 1 2 available so far, right? When 1 1 2 is available, so I will maintain the P0 in the safe sequence if it is successfully done. Now I got 1 1 2. Will this is going to be satisfied? Is 1 0 0 less than or equal to 1 1 2? Yes, satisfied. When it is satisfied, I am going to subtract the needed one. What is the needed one? 1 0 0 is the needed one. So the leftover available resources are 0 1 2. Now 1 0 0 is allocated to the process P1. So 1 plus 1, 1 plus 0, 1 0 plus 0, which means total allocated resources for P1 now are 2 1 0, and all it make it as 0, right? Yes. Which means that definitely at some point of time P1 also completed. I will make it in the safe sequence, and I will add back these resources to the already available resources for 0 1 2. Now what will happen? 2 2 2 are the available resources so far, right? Now check with the other process which are available. Yes, is 1 2 2 1 2 0 is less than or equal to 3 2? Yes. When it is available and it is satisfied the condition, I can able to apply the algorithm again. I can subtract 1 2 0 from here so that you can get 2 0 1. So 1 0 2 is available. Now this 1 2 0 will be added to this one, right? If it is added, you are going to get 1 3 0, right? Then I will make this as 0. So now after certain point of time, this P3 also will be lived. Now if P3 is a lived process, then already available resource is 102. For it, it is going to add 130 because P3 allocated resources are free. So we will get 232 are the available resources now, right? Is all the process are done? Yes. When all the process are done, is it equal to the total number of resources? Yes. Now our answer also got 2, 3, 2, right? So is there any where the process execution is halt or stopped? No. So if it is not, then if the system is in a deadlock state, so the answer will be no. The system is not in the deadlock state. So which means that you have to find the safe sequence. What is the safe sequence? P2, P0, P1, P3. That's it, right? So this is the safe sequence that you have to give as your answer. Hope you understood this particular gate question clearly.